So today we are going to see D and F block elements, quick revision. Okay, D and F block. So if you take this lesson, main two headings are one is it's a D block elements. Okay, so one is it's a D block elements, and then F block. So D block elements and F block elements. So what are the topics under D block elements means? So D block elements it is a transition elements. Otherwise it is called it is a transition elements. Okay, so transition elements. Um, so its a general configuration is this n minus 1, D 1 to 10, and ns 0 to 2. So this is it's the general configuration. So under D block elements, so the main two topics are, three topics are, one is its classification, properties, and important compounds of D block elements. Okay. So first topic is it's a classification. So what are the classification of D block elements? So D block elements classification is it's a 3D series. Okay, so 3D series, 4D series, 5D series, or 6D series. So all the uh, uh, four D series elements are there. First one it's a 3D series. 3D series or first transition series. So here the element from scandium. Okay, scandium atomic number it's 21 to zinc. Its atomic number is it's 30. So all these elements comes under 3D elements. Okay, then it's a 4D series. 4D series is starting from yttrium. Why? It's Z equal to the atomic number. It's a 39 to its cadmium. Its atomic number which is 48. So this is 4D. Okay. Then it's a 5D series. So 5D series of um, and that is the lanthanoid syndrome. It's lanthanum. Okay, lanthanum. Its atomic number is it's a 57. Then hafnium. Its atomic number is 72 to mercury. Okay, it's mercury. Its atomic number is it's 80. So all these are all 5D series. And then fourth classification, it is a 60 series. 60 series la actinum. Okay, actinum. Its atomic number is 89. Then it's a Rutherfordium. That is atomic number 104 to Copernicus. Okay, so it is a C. Cn is it's equal to 112. So these are the classification of D block elements. Okay, D block elements classification. இதுதான். So this is the first heading. Then second heading it's a properties of D block. So out of this transition elements, except zinc, cadmium, and mercury are not transition elements. They are only D block elements. The reason is fully filled d orbitals. Okay, it's only the incomplete d orbital only it belongs to its transition. But these three are it's fully filled. So these three are D block elements. Okay, yeah. So if you take the properties, so many properties are there. Only important properties, if you take an important properties, first one it's an atomic radii. It's an atomic radii. In first, second, and third series. Okay, so first this is first meaning of a 3D, 4D, and 5D series. Okay, first atomic radii decrease and then remains the same. Okay, atomic radii of third transition series, which is equal to second transition series, which is okay, um, which is less than first transition series due to lanthanide contraction. So I'll write here in first, second, and the third transition um, series. What will happen means first atomic radii decrease. First atomic radii decrease, and then remain same. So this is due to lanthanide contraction. This is due to lanthanide contraction. Okay. Then this is atomic radii. Smaller than actually its atomic radii is it's smaller than S block elements, smaller than those of S block elements and are larger than those of P block elements in a period wise. Okay. In a transition series, the atomic numbers increase of layers increases. The atomic radii first decreases and then remains சேம்னு பார்த்தோம். ஓகே ஸோ அண்ட் தென் அதாவது மிடில் வந்து இட்ஸ் சேமாக இருக்கும். தென் இன்க்ரீசஸ் டுவோர்ட்ஸ் தி எண்ட், இன்க்ரீசஸ் டுவோர்ட்ஸ் தி எண்ட். ஓகே ஸோ இது வந்து பீரியட் வைஸ். குரூப் வைஸ் பார்த்தோம்னா இட் யூஸ்வலி இன்க்ரீஸ் டவுன் த குரூப். ஓகே, increase down. It's down the group. Um, the size. Okay, so ionization enthalpy. So period wise, it is left to right. So that means it's left to right. Along the series from left to right, there is an increase in ionization enthalpy. Irregular trend in the first ionization enthalpy of 3D metal is it's due to irregularity in the electronic configuration because 3D orbitals are filled before 4s orbital. ஸோ அதே மாதிரி இப்போ குரூப் வைஸ் எடுத்தோம்னா அயனைசேஷன் என்தால்பி டிக்ரீசஸ் ஃப்ரம் 3D to 4D. ஆனால் 4Dலேருந்து 5Dக்கு வந்து இன்க்ரீஸ் ஆகும். ஸோ இப்போ இந்த irregularity வந்து இட்ஸ் டியூ டு lanthanide contraction. Okay, this is all about ionization enthalpy. Then it's oxidation state. Oxidation state is its variable. uh, um, Oxidation state is variable because the energies of ns and n minus 1d electrons are almost equal. Therefore, the electrons of both these orbitals take part in the reactions. Okay, due to which transition elements show variable oxidation state. இதுக்கு reason வந்து என்னன்னா energies of ns, energies of ns and n minus 1d orbitals are almost same. Okay. Orbitals electrons, actually orbital electrons are almost equal, the electrons of both these orbitals take part in a chemical reaction. So that is what it shows variable oxidation state. Okay, that is one property. Um, then if you take a melting point and boiling point, it raised to maximum. So it's raised to maximum and then decrease. Okay, then it's a decrease. Then catalytic properties. Then what about its catalytic properties? If you take catalytic properties, many of the transition metals and their compounds, particularly oxides, acts as catalyst for a number of chemical reactions. Okay, for example, if you take a iron, nickel, cobalt, platinum, chromium, manganese, and their oxides. Okay, so on their oxides and compounds are used as catalyst. So the reason and all transition metals show multiple oxidation state. Multiple oxidation state இருக்கிறதுனால they have large surface area. So all the metal work as catalyst. The reason வந்து because of multiple oxidation state. Okay, so because of multiple or variable oxidation state, um, they have and have large surface area. That's the reason for all these metals which acts as a catalyst. Okay, so that is a catalytic properties. Then if you take the magnetic properties, so we know that it's a diamagnetic and paramagnetic in render form. So okay, so here um, paramagnetic substances it is necessary to have paramagnetic at least one unpaired electron இருக்கும். Okay, um, paramagnetism வந்து it increases. Paramagnetism increases with increase in number of unpaired electrons. Okay. So இப்போ unpaired electrons if இருந்துச்சு அப்படின்னா அது வந்து paramagnetic. அதே மாதிரி paired electrons இருந்துச்சுன்னா அது வந்து it is a diamagnetic. So இப்போ இதுல வந்து paramagnetism may be, so this may be measured by paramagnetism may be it's measured by magnetic moment. So magnetic moment which is equal to root of n into n plus 2. It's in the bm வந்து it's both magneton, the unit of magnetic moment, where n is its number of unpaired electrons. Okay, number of unpaired electrons. Then it also forms complex formation. um, Complex formation. Complex formation is one of the important property of these elements. They have tendency to form a complex compounds due to high charge on the transition metal ions and the availability of d orbitals for accommodating electrons donated by ligands. Okay, availability of even if it is an empty. Okay, availability of d orbitals for ligands. Okay, for donating electrons. So there will be an orbital is there. Okay, so that is what it forms a complex compounds. Then colored compounds. It also forms colored compounds. The transition elements form colored ions due to the presence of unpaired electrons. Due to the இதுக்கு வந்து ரெண்டு reason. ஒன்று வந்து unpaired electrons, d electrons, and then DD transition. DD transition means light is absorbed in the visible region to cause excitation of unpaired d electrons. அதுதான் வந்து it is a DD transition. So because of this reason, they form a colored compounds. Okay. Um, Due to the absence of d electron, unpaired d electron means they will be colorless. Okay. Then it's a formation of alloy formation. Alloy formation. It's due to because it's due to small similar size of metal ions. Alloy formation is due to almost similar size of metal ions. What are the reason for this? Similar size. இதெல்லாம் நாங்க ரீசன் கொடுத்துருக்கேன்ல, இதெல்லாம் தான் கிவ் ரீசன்ல வரலாம். இதுக்கு என்ன ரீசன், அவைலபிலிட்டி ஆஃப் டி ஆர்பிட்டால்ஸ், இதுக்கு என்ன ரீசன், இதுக்கு என்ன ரீசன் இங்கே கொடுத்துருக்கேன். ஓகே, சிமிலர் சைஸ் ஆஃப் மெட்டல் அயான்ஸ், similar size of metal ions, high ionic charges, and then availability of d orbitals. Availability of d orbital electrons. D orbital electrons. So because of this, they form alloys. Okay. Then it forms interstitial compounds. Interstitial compounds. Interstitial compounds it forms again. The reason is small sized atoms. It forms an interstitial metals as small sized atoms of small sized atoms like hydrogen. Okay, like hydrogen, it's carbon, nitrogen, and the boron can easily occupy a position in the voids. Okay, voids present in the crystal lattices of transition metals can easily occupy. This is the reason easily occupy the voids present in the transition metals. Okay, so then next one, um, oxides of transition metals. Oxides of if you take oxides of transition metals, they may be basic, or they may be an acidic, or they may be an amphoteric because of the variable oxidation state. So here the reason, it is um, variable oxidation state. The reason is variable oxidation state. So அதில் வந்து அந்த oxides in the lower oxidation state are generally basic. Oxides in the lower oxidation state. இது ரொம்ப important. Okay, lower oxidation, which shows lower oxidation state, uh, they are generally basic in nature. Okay, so அதே மாதிரி higher oxidation states இருந்துச்சுன்னா, oxides in the higher oxidation states, higher oxidation state இருந்துச்சுன்னா, they may be either be amphoteric. Okay, amphoteric or acidic, mostly acidic or okay, amphoteric or acidic. So this is all about oxides of transition metals. The properties நம்ம பார்த்தோம்னா, இதோட properties, important properties வந்து அவ்வளவுதான். Okay. Then third heading under this D block elements are important compounds. What are the important compounds? Important compounds நம்ம பார்த்தோம்னா, it's potassium dichromate and potassium permanganate. Okay, so K2, Cr2O7, and then KMnO4. So these two compounds are important. இதுல வந்து என்னென்ன இருக்கும்னா, preparation, properties and uses. So இதுல just ஒரு preparation of potassium dichromate வந்து equation மட்டும் நம்ம பார்க்கலாம். So it is obtained from um, sodium dichromate இருந்து Na2Cr2O7. So with 2 KZl gives K2Cr2O7 and then 2 NaCl. So this is the preparation for potassium dichromate. Potassium permanganate பார்த்தோம்னா, potassium manganate இருந்து prepare ஆகும். 2 K2MnO4. இந்த equation நல்லா பார்த்துக்கோங்க. Cl2 gives 2 KMnO4 plus 2 KCl. Okay, so this is the preparation for both. Properties நம்ம பார்த்தோம்னா, so this is orange color crystalline solid. Okay. Orange crystalline solid. Then its melting point. Melting point நம்ம பார்த்தோம்னா 669 Kelvin. இது வந்து soluble in cold water, moderately soluble in cold water, but free soluble in hot water. Moderately soluble in cold water. Okay, but easily soluble in hot water. In hot water. So this is one of the powerful, strong oxidizing agent. Okay, strong oxidizing agent. So these are the important properties of potassium dichromate. இப்போ அதே மாதிரி இப்போ பொட்டாசியம் பெர்மாங்கனேட்டுக்கு நம்ம பார்த்தோம் அப்படின்னா இது வந்து டீப் பர்பிள் கலர். ஓகே, ஸோ டீப் பர்பிள் the color crystalline compound, and then its melting point is it's 513 Kelvin. அதே மாதிரி it's moderately soluble in water at room temperature, more soluble in um, hot water. It's soluble in water. Okay, it's moderately soluble in room temperature, but if it is a hot water, means it's easily soluble. Again, this is also it's a powerful oxidizing agent. Okay. Okay. So this is properties. Then, if you take uses, what is the uses of this? Potassium permanganate, it is used in leather industry. Okay. Uh, Leather industry and calico printing and dyeing. Printing and dyeing, like, it is used. Printing and dyeing, and in photography and botany, gelatin flame. In photography, it is also used in photography. But here, uses of potassium permanganate, it is a base reagent. Okay, reagent are used of. So base reagent means it's alkaline potassium permanganate. It is called its base reagent. சிம்பிளா நீங்க KMNO4 is base reagent எழுத முடியாது. ஏன்னா இது வந்து அசிடிக்கும் இருக்கும், ஆல்கலைனும் இருக்கும். ஸோ ஆல்கலைன் பொட்டாசியம் பெர்மாங்கனேட் தான் இட் இஸ் அ base reagent to test unsaturation in organic compounds. Okay, to test நம்ம addition reaction யூஸ் பண்ணுவோம் to test unsaturation in organic compounds. And then it is also used as a disinfectant and germicide. And then it is also used as a bleaching agent. Okay, it is used as a bleaching agent in wool, cotton, silk, and other textile fibers. Okay, so these are the uses of potassium permanganate and potassium um, dichromate. Okay, so the D block elementsல வந்து இம்பார்ட்டண்டா உள்ளதை வந்து நம்ம டிஸ்கஸ் பண்ணோம். ஸோ அகெயின் சொல்லி இதில் வந்து மோஸ்ட்லி உங்களுக்கு வந்து ஒய் கொஸ்டின்ஸ் நிறைய வரும். ஓகேயா? ஸோ இப்போ நெக்ஸ்ட்டு வந்து இட் இஸ் எஃப் பிளாக் எலிமெண்ட்ஸ். F block elements, otherwise it is called, it is inner transition. Inner transition elements. Inner transition elements. இதுலையுமே வந்து its configuration, its general configuration is n minus 2 f 1 to 14. Okay, n minus 1 t 0 to 1 n s 2. So this is the general configuration for f block elements. Okay, yeah. Again இதுலையுமே வந்து its classification, ப்ராப்பர்ட்டிஸ் ட்ரெண்ட்ஸ் என்ன அப்படிங்கிறது வந்து இதிலே பார்க்கலாம். இட்ஸ் கிளாசிஃபிகேஷன். கிளாசிஃபிகேஷன் பார்த்தோம்னா 4F series and 5F series. 4F series, otherwise it's called lanthanides. lanthanides 4F series. So இதில் வந்து it is CE cerium 2 cerium 2 Z வந்து it is 58 to Lu. Its atomic number is 71. Okay, then actinides it is a 5F series. இதில் வந்து it's TH thorium it's 90 to uh, fluorentium it's Z atomic number is 6103. Okay, so this is the classification of F block elements. Okay, yeah. So இப்போ இதுல trends and characteristics of lanthanoids and actinoids வந்து என்னன்னு பார்க்கலாம். Uh, trends in um, trends and characteristics of lanthanoids. It show common first வந்து என்னன்னா it show common stable oxidation state. Okay, stable oxidation state plus 3 வந்து எல்லாத்துக்குமே வந்து it's common. Okay, then it's regular decrease in atomic radii with increase in atomic number, which is called lanthanoid conduction. With increase in atomic number. So, it is a lanthanoid conduction. Okay. So then they have low ionization enthalpy, and high boiling point and melting point. Okay, high boiling point and melting point. They form colored compounds. Okay, yes. Form colored compounds. Colored compounds due to FF transition. Okay, so due to FF transition, um, color is due to FF transition. So that is the one thing. So another one, it's a magnetic properties. Magnetic properties நம்ம பார்த்தோம்னா, so among lanthanoids, lanthanum La3 plus and Lu3 plus, which have uh, 4F0 and 4F14 இருக்கும். Okay, so இதுக்கு வந்து respectively வச்சுக்கேன். So this is 4F, இது வந்து 4F14. Okay, electronic configuration இருக்கும். So or diamagnetic, இது வந்து it's a or diamagnetic. ஏன்னா paired electron unpaired electrons வந்து இருக்காது, and other trivalent lanthanoid ions are paramagnetic. Others are paramagnetic. Paramagnetic due to the presence of unpaired electrons. Due to the presence of unpaired electrons. Okay, so this is all about its magnetic properties. Uh, so because of lanthanoid contraction, atomic size பார்த்தோம். But what is the okay, next பார்த்தோம். So oxidation state பார்த்தோம், colored பார்த்தோம். Okay, what are the consequences of lanthanoid contraction? Consequences of lanthanoid contraction வந்து இதுல என்னன்னா it leads to similar physical and chemical properties among the lanthanoids. Okay, uh, similar physical and the chemical properties. Chemical properties among lanthanoids. அதே மாதிரி இப்போ நெக்ஸ்ட் வந்து பார்த்தோம்னா ZR zirconium and hafnium have same properties. Okay, have same properties due to atomic size வந்து same இருக்கும். Okay, properties uh, due to same atomic radii. Okay, due to same atomic radii. Then chemical separation of, so because of that separation, okay, even chemical separation are very difficult of lanthanoids. Lanthanoids are, it's very difficult. So these are the consequences of uh, lanthanoid contraction. Okay, so its chemical properties நம்ம பார்த்தோம்னா it's a lanthanum lanthanumனு நம்ம எடுத்தோம்னா so இது எல்லாமே வந்து +3 oxidation state இருக்கிறதுனால so it's easy yeah, uh, it forms its LnC3 with the carbon and with the oxygen. It forms Ln2 O3, and with the sulfur it forms Ln2S3. So because of the oxidation state 3, okay, with the nitrogen it forms Ln. Then it's with water it forms a hydroxide LnOH thrice, and with halogen it forms LnX3. Okay. Then with acid it forms with the liberation, it forms a salt with the liberation of hydrogen gas. Okay, so these are its chemical properties. The uses பார்த்தோம்னா mish metals. Okay, mish metals தான் ரொம்ப it's very important. MISCH is the mish metals. In the alloy of இதுல வந்து alloy of என்னென்ன இருக்கும்னா it's a cerium. Okay, alloy of cerium it's a 25% and various other lanthanoid elements. Okay, lanthanoid elements. It contains அதை தவிர it contains iron வந்து 5% இருக்கும், and then it's a traces of sulfur. Okay, traces of sulfur, carbon, silicon, calcium and aluminum. Okay, so in the lanthanol the mish metals வந்து அந்த bullets and இதெல்லாம் இருக்கு இல்லையா, ஸோ அதுலலாம் யூஸ் ஆகும், guns, bullets, it's making வந்து இது வந்து ரொம்ப யூஸ் ஆகும். So this is all about lanthanoids. Okay, then if you take actinoids. Actinoids properties. uh, Actinoids properties and trends. All metals, all actinides. Actinides, it show +3 oxidation state. Okay, +3 oxidation state. They are highly reactive metals. It's highly reactive metals. They are very highly reactive metals. All metals are radioactive. All metals are radioactive, so they are generally colored, colored compounds. So these are the magnetic properties. Many ions or many actinoid ions are paramagnetic. Okay. Then it's if you take a chemical properties, less reactive towards acids. ஸோ ஆக்டினாய்ட்ஸ் பொறுத்த வரைக்கும் இதுதான் இது ப்ராப்பர்ட்டிஸ் வந்து நம்ம ஓவர் லாக்டனாய்ட்ஸ் அண்ட் ஆக்டினாய்ட்ஸ் ஓவர் டி அண்ட் எஃப் பிளாக்கே ஓவர். இப்போ இதில் இன்னொன்று என்ன இம்பார்ட்டன்ட் அப்படின்னா டிஃப்ரென்ஸ். டிஃப்ரென்ஸ் வந்து ரொம்ப இம்பார்ட்டன்ட்டு. வாட் இஸ் த டிஃப்ரென்ஸ் பிட்வீன் லாந்தனாய்ட்ஸ் அண்ட் ஆக்டினாய்ட்ஸ்? Lanthanoids and actinoids. என்ன டிஃபரன்ஸ்? இது வந்து இட்ஸ் 4f ஆர்பிட்டால் இல்லையா? 4f ஆர்பிட்டால்ஸ். 4f ஆர்பிட்டால்ஸ் இஸ் progressively filled. ஓகே, இஸ் filled. அதே மாதிரி இங்க பார்த்தோம் அப்படின்னா இட்ஸ் 5f ஆர்பிட்டால் வந்து ஃபில் ஆகும். 5f ஆர்பிட்டால் ஆர்பிட்டால் ஓகே. ஸோ இப்போ இங்க வந்து +3 ஆக்சிடேஷன் ஸ்டேட் இஸ் காமன். +3 இஸ் காமன். Then and along with common along with +2 and +4. இங்க வந்து +3 தான் இட்ஸ் மோஸ்ட் காமன். அது தவிர இட் ஆல்சோ எக்ஸிபிட். ஓகே, மோஸ்ட் காமன் வந்து இட்ஸ் +3 ஆல்சோ எக்ஸிபிட் +4 to +7. Okay, so இங்க then third difference is except promethium. Okay, except promethium all are non-radioactive. Yes, so all are non-radioactive, but இங்க பார்த்தோம்னா எல்லாமே all are radioactive. Radioactive. Uh, less next property பார்த்தோம்னா it's a less tendency towards the formation of complex compound. Okay, less tendency to complex formation. Tendency to complex formation. But இங்க பார்த்தோம்னா it's a strong tendency. Strong tendency to complex formation. Then final point, இதில் 3 more question வரலாம் உங்களுக்கு. Chemically less active. Chemically less active than actinoids. இது வந்து it's more active than lanthanoids. Okay, so these are the difference between lanthanoids and actinoids.